Hi everyone, so today we'll discuss the problem we find a permutation from Codeforces around 997 div 2. Okay, so we are given an undirected graph of n vertices labeled from 1 to n. This graph encodes an header permutation p of size n, and the graph is constructed as follows. For every pair of integer ij 1 to n, an undirected edge is between vertices pi and pj if and only if pi is less than pj. Basically, question is saying there is permutation of size n, p1, p2, p3 up to pn, and graph is constructed as like if some pi is less than pj, the edge is connected between I and j. So there is node I and j. Edge is there when pi is less than pj. So like this, a graph is constructed from the permutation. Your task is to reconstruct and output the permutation P. It can be proven that P is uniquely determined. Permutation P can be uniquely determined. And each line G1, G2 urgency matrix Gij is 1 if and only if there is a H between I. Basically, mm, question is like from permutation a graph is constructed. Now we have given this graph. Now we have to reconstruct this permutation. So in the input, this graph will be given. On the output, we have to print the permutation. So let's see the test cases. First is n means there is only one, so there won't be any edge as there is only one node, so it is 0. So permutation is also only one. Let's see the second TC. So n is 5, so there are 5 nodes. One is connected to, there is a node between 1 and 3 and 1 and 5. You can see from the graph 1 is connected to 3 and 1 is connected to 5. Then 2 is connected to 3, 2 is connected to 5, 2 is connected to 3, 2 is connected to 5. Then 3 is connected to 1, 2 and 5. 3 is connected to 1, 2 and 5. 4 is connected to 5. 4 node 4 is connected to node 5. 5 is connected to all other 4 nodes. So 1, 2, 3, 4. So this is the graph. So we are given the graph. We have to output the permutation P that would have been used to construct this graph. So if you see, this is a valid permutation because there is a path between age between 4 and 5 because 4 is less than 5, like pi is less than pj. For 2 also, 2 there is a age between 2 3 and 2 5. 2 3 and 2 5 as 2 is less than 3 and 5. For 1 3 5, so 1 3 and 5. For 3 it's 5. So this is exactly the p of this permutation of this graph. Yeah, so this was the question. Uh, there can be many solutions for this. See, I solved using recursion. Like divided the problem into smaller problem and then merge it to give the result. So consider like I have there are 5 nodes, means there are like they can be P1, P2, P3, P4 and P5. Now it can be 1, 2, 3, 4, 5. I want to I will take the last like maximum number P5 and I want to keep all other element if there is an edge from P5 to other, like if there is an edge from P5 to P1 in the graph, then I will keep P1 here. Suppose P4 is also there, then P4. If it is not there, I want to keep after 5, like P2 and P3, so that the condition won't hold true for this. Like Pi is greater than Pj, so no edge, no edge. In the Clown shuffling, if you see, if and only if Pi is less than Pj, so edge is there only when Pi is less than Pj. So if from P5 to P1, if there is an edge, then I will keep P1 before P5. Similarly for P4, if there is no, then I will keep after 5, so that this condition hold true, which signifies no edge. Yeah, so I will then solve the same for this problem and this problem, and will combine to give me the last permutation as a result. So if I show you the code, then it will be more like understandable. Okay, so I input n, then I input the adjacency matrix, whatever we are given the input. Then I have the initial curve, which I will send with all from 1 to n. I will push all number 1 to n, and I will call helper to generate the permutation for this 1 to n based on this graph, and I will output that result. In the helper, if the size is 0, then answer is empty vector. If there is only one element, then that element itself is the permutation. There won't be any other, so we don't have to care about the age. Otherwise, we will find the maximum element. Like here, P5 is maximum, and I will have two vector left and right. So if I will iterate through the curve, and if I will skip for the max for other element, if I will check if there is a path from mx to x, then I will put it to the left as I explained here. If there is a path, then I will put to the left vector this max to that element. Otherwise, I will put to the right vector, and I will solve these two in other sub problem, and then I will combine it to the result. So put if there is a edge, then I will put in the left vector, otherwise right vector. Then I will call the helper again to solve the left vector and right element. After that, I will combine the results. I will result left, then the max, then the right element, and return the result. So this was all for this question. So yeah, I hope you understood it. If there are any doubt, you can ask me in the comment section. Thank you.